Okay, so we're going to be graphing sine and cosine today. So instead of looking at our unit circle, remember back to when I said, imagine that we have a circle and this is the real number line wrapped around the circle, correct everybody? Now instead of having it on a unit circle, we're going to put it on an XY chart, an f of x chart. So we're going to be graphing it out. So we're going to first focus on sine. So remember that sine is our y values on the unit circle. Sine is y values. So we're going to just be focusing on our y values here. And we're going to be graphing what we're seeing. Now we have 4 quadrants. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're basically going to be graphing what's going on between those 4 quadrants. That is exactly what we're going to be doing here. So notice once again, our sine is our y values. Notice at 0, we're at 0, correct? We're just plotting xy points. So at 0, our function is at 0. Everybody good with that? I'm going to change to blue. So we're literally going over here. At 0, we're at 0. Everybody feeling comfortable? Now are you focusing? Okay, so now look at our y values. Aren't they going positive? A little bit higher till we reach 1? Yeah. So they're going up till we hit 1. Now when did we hit 1? At pi halves, right? So we were going up till pi halves. We were up at 1. Does everybody see that we were going up till we hit 1 at pi halves? Now after pi halves, aren't our y values then going back down, getting smaller till we hit 0. So now after pi halves, we're going down till we hit pi. It'll be our function is 0 at pi. So now we're going down. Everybody seeing this? Now after that, look at my y values. Negative, they're all negative. So now we're going into the negative y direction. Does everybody see here? So now we're going down into the negative till at 3 pi halves. So we're going negative till at 3 pi halves we're at -1. So now we're going down till at 3 pi halves we're at -1. Then after that, notice we're negative, but it's getting larger and larger here. So now we're going back up till at 2 pi. We're going back up, even though they're negative, we're going back up till at 2 pi, which is right here, we're back to 0. Now we have just graphed a full cycle of sine. Does everybody see how that works? So I want you to notice a couple of things when graphing. We're going to graph what's happening between the quadrants. So anytime I'm graphing sine, unless it's shifted, we'll talk about that later, but I put down these 4 specific places. So I'm always going to go tick mark 1, 2, 3, 4, and then I just put in pi halves, then pi, 3 pi halves, 2 pi, because that's where I would be going around the circle. Does everybody understand? Now I just want you to notice something. I just kind of give this as a trick. So we started at 0, we ended at 0. That's how we know we've done a full cycle. This just is a little dumb trick. It doesn't even really work, but do you see how this kind of looks like an S sideways? If you squint one eye, close the other, tilt your head sideways. A sideways S. So that just kind of helps me go, okay, now I've drawn in my full cycle because I've drawn in my full S. Anyways. All right, sweet. Like a squiggly S. But that just kind of helps me know I've graphed one full cycle. Okay, let's do cosine. So y is equal to cosine of x. Remember that cosine are the x values. So once again, we're graphing what's happening between the 4 quadrants. So how I'm going to do this one is 0's here, correct? Yeah. So it looks like a sideways S kind of. So look at cosine. So cosine is our x value. So here's 0. Then we're graphing what's happening between the 4 quadrants. So the next one will be pi halves. Then it will change. The next one will be pi, correct? We're graphing what's happening in between. Does everybody understand? 3 pi halves. It'll change again. It'll change direction or maybe not. And then 2 pi. Because that means we've gone around a full circle, so that's a full cycle. So let's graph this. So XY points. At 0, cosine is at 1, correct? So notice, cosine at 0 starts up at 1. Does everybody understand? Okay, then as we go up, we're getting smaller and smaller till we hit 0. Remember that we're focusing on x values. So we're getting smaller and smaller. We're going down, down, down till at pi halves, we're at 0. So we're going down, down, down till at pi halves, we're at 0. Then after that, remember we're x values. So now look, my x values are into the negative direction. So we're going down, down, down till we hit -1. At pi, we're at -1. So go to pi, we're at -1. You're going down, down, down till we hit -1. And then it starts our x values, sorry. My x values are still negative, but they're getting larger and larger till they go back to 0. So now they're going up, up, up till they hit 0 at 3 pi halves. We're up at 0. And then after that, our x values climb up back to 1. So then they're climbing, climbing, climbing till at 2 pi, we're back to 1, up at 1. And this continues, so this is going to keep going, because think about it, can't I go around the unit circle again and again? So this is just going to continue, continue, continue. That'd be going around the unit circle. I did that 4 times. Does that make sense, everybody? Everybody good? Yeah. So I probably, if I was being a little bit prettier, which I'm going to make it a goal to be, put arrows, because that's really continuing. So now, once again, notice that cosine kind of, if we want to learn a little trick, it starts up here and kind of looks like a sideways. If you squint one eye, close the other, turn your head sideways, it kind of looks like a sideways C instead of the S. That's one full cycle, okay? So a dumb little trick, but it helps me because once we start graphing these, those will help you. Questions on how to graph this, okay? Now, here's some vocabulary to know if you want to write it down. You're going to need to know the vocabulary really well. And I think I understand graphing these so well because I know what the vocabulary means, and that comes from teaching it many years. So you're going to want to really intake this vocabulary and understand it. So period. Write this down. Period means the physical length of one full cycle. So that would be going around the unit circle once. So this is the physical length of one full cycle or one revolution. So looking at y equals sine of x, the length of one cycle, so we started at 0, and this was one full cycle, right? Everybody, that would be just going around the circle one full time. So the length of this particular, for y is equal to sine of x, the length of one full cycle was from 0 to 2 pi. That's a distance. So the physical length of one cycle is 2 pi. Everybody good? So right now we're just trying to get what does period means. It means the length of one cycle, the physical length. Amplitude is how high up or down from the midline. So this is a distance. So this is my midline. Ding, 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 ding. So how high up? 1. How high down? -1. So my amplitude is always positive. We're talking distance, which distance is positive. So we're always going to do the absolute value of A. So my amplitude is 1 for y equals sine of x. From the midline, it's 1 up, and from the midline, it's 1 down. So our amplitude is 1. How high up or down it's reaching from midline. All right, so let's think about domain and range for sine. So think about it. I can go around the unit circle once. I can go around twice, 3 times, 4, 5. I can keep doing that all day long, every day. So won't our domain be negative infinity to positive infinity for sine? Can't we just keep going? Okay. Our range is the possible y values. For y equals sine of x, we know our amplitude was was 1. So it reached our functions bouncing between -1 and 1, correct, everybody? So our range would be -1 to 1, including both those points. Okay, so looking at cosine, once again, cosine means, cosine period means the physical length of one full cycle. So for cosine, the full cycle was the C, and notice this length for y equals cosine of x, our period, the physical length of that one cycle was 2 pi. physical length of one cycle. And our amplitude, it's bouncing from the midline. Our function's bouncing between +1 and -1. So our amplitude for this would be 1. And our domain, once again, we can keep going around the unit circle. So for cosine, our domain is -infinity to infinity, because we can draw in as many cycles as we want. Ding, ding, we keep going. Our range is -1 and 1. So hopefully you're just a little bit comfortable with some vocab now. Period is physical length of one cycle, and then amplitude is how high up or down from midline. Okay, so when we graph these, this is what's going to be expected on the test and on your homework. You're going to be expected to graph 2 cycles. 2, not just 1, always 2 cycles. So let me just show you really quickly how we would graph 2 cycles for sine. So let's think about it. Going around the unit circle once, we're at the 4 key points. So we were obviously starting at 0, then we were at pi-halves, right, everybody? And then we were at pi. Is everybody understanding? Because I need to make sure. And then we have 3 pi-halves. And then we have 2 pi. So notice, 1, 2, 3, we put in 4 tick marks, and then we went around once would be putting us at 2 pi, correct? So then we could use our knowledge to figure out these values. So you could think of this a few different ways, even though we've already written these in there. I just want to point out something. Couldn't I have figured out that this is pi, because isn't that halfway between 0 and 2 pi? Does everybody see? That's how I do it from here on out. And then from here, this is the halfway distance between 0 and pi. So that would be pi plus 0 is pi, and then divided by 2. So that's pi-halves. Now look, 2 plus 1 pi is 3 pi's. Now we're dividing it by 2. That puts us halfway between. Does everybody see? Okay, so now I'm going to ask you, if we go another full revolution, where is that going to put me here? 4 pi, correct? Another 2 pi, another revolution here. So halfway between would be 6 pi divided by 2 is 3 pi. Now we could keep doing that. 3 pi plus 2 pi is 5 pi divided by 2. So won't this be 5 pi-halves? Now let's see why that makes sense. 1 pi-halves, 2 pi-halves, 3 pi-halves, 4 pi-halves, 5 pi-halves, 6 pi-halves, 7 pi-halves. So there's so many ways you can think about how you want to fill that in. Everybody good? And now we would draw this. So what happened with sine? So remember that sine kind of looks like an S, correct? Okay, so it started at 0, 0, correct? Then it went up to 1, back down to 0, correct? Back down to -1, and then up to 0. So there was 1. So hard for me to see with my hands. Then we would go another revolution. So we would be up again at 1. Then it went back down to 0. Then it went down to -1, back up to 0. So we're going to have to draw in 2 revolutions here. Yes. Well, we'll get lots of practice in. This is all we're doing today is just graphing. Okay, so let's do 2 revolutions for cosine. So won't these values be the same for cosine? Everybody, right? So we would have our pi-halves, pi, 3 pi-halves, 4 pi-halves, which is 2 pi, 5 pi-halves, 6 pi-halves, which is 3 pi, 7 pi-halves, and 2 pi. And then remember that cosine kind of looks like a C, correct? 4 pi. Good point. Okay. All right, I'm going to scroll up so I don't have to bend over. Okay, here we go. So this kind of looks like a sideways C. So remember that cosine starts at 1, correct? Is everybody remembering the pattern? Because if I'm not making sense, you're going to have to tell me. So then it goes to 0, correct? Then it went down to -1, back up to 0, and then back up to the top point. Ding, ding. Now we're doing another circle. So it started up here, just like it did here. Came back down to 0, -1, back up to 0, and then back up to the tippy top point. Ding, ding. Pretty cool. Okay, awesome. Questions? Okay, so now let's do one and 1. So amplitude is the distance up or down from the midline. So everybody, we know that it's absolute value of A. Now this is where amplitude will be located in the equation. Y is equal to A sine of X. That's the amplitude. Now this is our vertical stretch or compression. So instead of being at 1, it might be stretched to 2. If it's at a half, then it might be compressed a half down. So once again, amplitude is just how high up or down from the midline. It works the same for sine and cosine. So everybody, let's look at this. We're going to graph 2 cycles of y is equal to 2 sine of x. So first of all, our amplitude is 2. Does everybody understand? So we're going to be going, instead of up 1, up 2, and down to negative 2. Now, we would say we're going to graph 2 cycles. So 1, 2, 3, 4. 4 quadrants, that would be from 0 to 2 pi. Right? Everybody? Yeah. And then halfway between those is pi. Halfway between 0 and pi is pi plus 0, which is pi. Then divide it by 2. Find the average of that distance. That's pi halves. 3 pi halves. 4 pi halves. 5 pi halves. 6 pi halves. 7 pi halves. And 8 pi halves, which is 4 pi. And now we're just drawing it in. So sine looks like an S. But now we're going up to 2. So 0. Now at this point, instead of up to 1, we're up to 2. Then we're back down to 0. Instead of at negative 1, we're now at negative 2. And back up to 0. I'm going to draw in that cycle. Ding, ding. And now we'll draw in another cycle. So at 5 pi halves, we'll be up to 2. Back down to 0. Down to negative 2, and back up to 0. So I've drawn in my second S, my second cycle, and so I'm done. Pretty good with amplitude. Sorry, I'm going to say that again. Our domain is still negative infinity to positive infinity, because we can keep drawing in as many cycles as we want. Our range now is from negative 2 up to 2. Okay, any questions?
So is your range always
Yep, exactly. Yep, so I just want you to look at these. I've already drawn them. You don't need to draw them in. Compare that y equals just sine of x, the red, versus 2. Do you see how they still have the same x-intercepts, everybody? And then they still have like the same x values. It's just higher up at 2, higher down at negative 2. So, anyways. Yeah, good question. Okay, now so you'll want to write this down. This is the hardest one, the most missed one for students, is they just think wrong about this. So now we're going to look at amplitude and period. So now we're talking an equation that will have the form of this. Y is equal to A sine of parentheses B times X, and Y is equal to A cosine of B times X. So A is still the amplitude. And then B is not the period. That's where students get mixed up. They'll say B is the period. That's not true. B is the number of cycles we're going to have from 0 to 2 pi. So B is the number of cycles you're going to have drawn from 0 to 2 pi. On the interval 0 to 2 pi, that's the number of cycles you'll have. Period is the physical length of one cycle, and this is how we get it. We do get our period using B. This is the formula we use for period. So period is 2 pi divided by B. So we are going to use that B to find the length of one cycle. You just got to remember and memorize and remember that formula. Period means the physical length of one cycle. And remember, we're going to need to know that because we're drawing in 2 cycles. So physical length of one cycle you'll find by doing 2 pi divided by B. And then we can go ahead and graph that. And you'll see how this is going to work. This isn't too bad. You'll see. So let's do our first example. Now, take my suggestion. If you always write down these steps, it always helps. It never hurts to write these things down. So, example number 1. We have y is equal to sine of 1/2 x. So we have something of the form y is equal to sine of bx. Okay. So let's first list out what our amplitude is. Isn't our amplitude 1? Okay, so now we go over to my graph. We're going up to 1 and down to negative 1. Does everybody understand? Okay, moving on to the number of cycles from 0 to 2 pi. Well, that's just b value. How many cycles are there going to be from 0 to 2 pi? 1/2. We're only going to have a half of a sine cycle drawn stretched over 2 pi. Does everybody understand? Okay, now let's find the actual length of one full entire cycle, because we don't want just a half a cycle, we want 2 full cycles. So let's figure out period means length of one cycle. So what's the length of one cycle? So you'll use your formula 2 pi divided by b. So won't that be 4 pi? Dividing fractions is easy as pi. We flip the second fraction and multiply. So the physical length of one full cycle is 4 pi. Has everybody caught up to me mentally? Now we need to draw in 2 full cycles. So let's just do our tick marks for the first cycle. 1, 2, 3, 4. Because remember, we're graphing over 4 quadrants. So the length of one full cycle was 4 pi. Is everybody understanding? Now we're going to need to go another full cycle. So let's go additional 1, 2, 3, 4. So what will that put us at? 8 pi. Is anybody confused? So let's fill in these tick marks. So halfway between 4 pi and 0 is 2 pi. So right here is 2 pi. Halfway between 4 pi and 8 pi is 6 pi's. Now 0 and 2 pi, that will put us at, okay, so this is 1 pi, 2 pi, that'll put us at 3 pi, 4 pi, that'll put us at 5 pi, 6 pi, 7 pi, 8 pi. So we've listed out our x-axis here. So let's now draw in 2 cycles. So we're going up to 1, so remember sine looks like this. So we start at 0 up to 1, right? Next point we're at 0. Next point we're at -1. Then back up to 0. So there's one cycle. Ding, ding, ding. Now let's draw in our second cycle. It looks like this. So we go up to 1, down to 0, down to -1 at 7 pi, and up to 0 at 8 pi. And then draw in your arrows because it is continuing. We could draw in as many cycles as we need. So now you've done one with our x values being stretched out. So now think about it, guys. We were just barely, when we were just looking at y equals sine of x, we were only, like, we were kind of focusing in on this interval. So do you see how it's like, I always use the wrong word, but like, it's much, like it's compressed out, correct? Yeah, see, I always say it backwards. No, it's compressed. See, I like to say stretched, but it's not stretched out. It's like compressed out. 1/2? No, remember it's a vertical compression though. So remember, so we're pushing it down. Here's what we're doing. So are we taking the normal one and compressing it down? Do you see how then that pushes it out? Does that help a little bit? I do the same thing. I'm like, oh, it's stretched out. Yeah. You crush it. Yeah. Yeah, it compresses it this way. Yeah, I know, right? Okay. Okay, let's do one more. Or do you not need one? Do you want one with cosine? Okay. Here we go. Amplitude is? 3. Number of cycles from 0 to 2 pi. That's the no, B is the number of cycles, but you're almost there. So the number of cycles we're going to have from 0 to 2 pi is 2. But then our period is, you're right, your period is 2 pi divided by 2, guys, right? So our physical length of one full cycle is pi. So we're going to go up 1, 2, 3, down 1, 2, 3. And now we're having to draw 2 cycles. Remember, period means physical length of one cycle. So we're going to go like this. 1, 2, 3, 4. That would be one full cycle. And we're going to be at, the length of one cycle is going to put us at pi for this one, correct? And then another full cycle. 1, 2, 3, 4 will put us at 2 pi, correct? Now that makes sense. We're going to have 2 cycles from 0 to 2 pi. Okay, now let's fill in these. So halfway between pi and 0 is pi halves, right? Halfway between 0 and pi halves is pi fourths. So there's 1 pi force, 2 pi force. This will put us at 3 pi force, 4 pi force, 5 pi force, 6 pi force, which simplifies to be 3 pi halves, 7 pi force, and 8 pi force, which is 2 pi. Okay, now we can graph it. Then remember, cosine is the C-looking one. So this one starts up with the amplitude. So it starts up at 3, goes down to 0, correct? Then here we're at -3, back up to 0, and back up to 3 at pi. There's one full cycle, ding, ding. And then starting a new cycle, we'd be at 0, -3, 0, and up 3. Now I'm drawing in my second cosine. How do you feel? Yeah. Okay. So we don't need to do this one, I don't think. Okay, so my amplitude is 8. Number of cycles from 0 to 2 pi is a half, correct? There's only a half a cycle of cosine. Now our period is 2 pi divided by 1/2, so won't it be 4 pi? So then we would go up, I'm just going to call this 8, -8. 1, 2, 3, 4. The length of one cycle puts us at 4 pi. 1, 2, 3, 4, 8 pi. Split in half, it would be 2 pi. So aren't these pi's? 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. So now cosine looks like this. So it starts up at 8, 0, -8, 0, 8. We've drawn in our first cycle. And then 0, -8, back to 0, up to 8. So I didn't draw that very good at all, did I? Okay. Okay. All right. So we can get to these last two before lunch, and then we'll be golden to come back. So everybody, look at this. Do not call the amplitude -2. No such thing as a negative amplitude. Our amplitude is 2. What that negative does is just remember, it's a reflect. Very good at remembering that. That's a reflection over x-axis. So watch. You don't have to take notes during this. Our amplitude is 2. The number of cycles from 0 to 2 pi is 1. Period is 2 pi divided by b, which is 1. So the length of one cycle is 2 pi. So we're going to go up 1, 2, down 2. Now we're going to list our x-axis. So we've got to draw in 2 cycles. 1, 2, 3, 4. That'll put us at 2 pi. 1, 2, 3, 4 will put us at 4 pi. Now we would fill in the x-axis, right? So that's pi, pi half, 3 pi half, 5 pi half, 3 pi, and 7 pi half. Okay, so then from there, we've got to be careful, watch. So normal sine looks like this, correct? Everybody? So now we're going to start at 0. Because isn't 0 reflection 0? Over. Instead of going up first, are we going to be going down first? Instead of going up, now we're going down, correct? So now we'll go down to -2 at pi. 0 will reflect as 0. Then we'll be up here. And then back down to 0. So it's just reflected the other way. Is everybody seeing? So we'll go down first because it's a reflection, back up to 0, and up, back down to 0. So now we've drawn in a reflected sine with amplitude 2. Okay, let's do this one so that we can get to the more difficult problems so that we cannot rush those. No. Okay. Anyways, so are we paying attention? So my amplitude is what for this one? 1, right? Then just a reminder, the negative is just a reflection over the x-axis and that our amplitude can't be negative. Okay, so then number of cycles from 0 to 2 pi. How many cycles do we have from 0 to 2 pi? 2. Our period is 2 pi divided by b. So 2 pi divided by b, so it's pi. So over 1, 2, 3, 4. 1, 2, 3, 4 puts us at pi. 1, 2, 3, 4 puts us at 2 pi. I didn't spread that out very good, so that's not going to be very pretty. Our amplitude's 1 and negative 1, so it's just 1. And then because of the reflection over the x, just a reminder, cosine looks like this. Oops. So now instead of being up here at positive 1, won't we start at negative 1? We're reflecting that point. 0 will stay over 0. This used to be down here. We're now reflecting it, so it'll be up here at 1, 0, negative 1. Same thing. 0 up to 1, back down to 0, and down to negative 1. So we have our 1 cycle, 2 cycle. Okay. All right, next thing, translating sine and cosine. So that was the easiest thing, but now we're going to have shifts left and right and shifts up and down. So recall that shifting for all functions works the same. So just look at these. These are some things we've graphed or seen in the past or even this year. So this is a quadratic. It's shifted right 1, up 3, stretch to 2, correct? This is a cubic that would be shifted right 4, up 3, stretch up 2, and a reflection over the x-axis. Right? We know that shifting for functions works the same for all functions. So this is left 1. This is an absolute value function. This is left 1, down 4, stretch of 3, reflection over the x-axis. So square root, this would be, you told me to shift. Right 3, down 5. Stretch of 4. Okay, so now shifting for all functions works the same. So if you have a function that has this form, y is equal to a sine of bx minus c plus k. A is our amplitude, like we've already seen. B is the number of cycles from 0 to 2 pi. We can find the period using b, using the formula 2 pi divided by b. Now, the shift left and right is a little bit trickier because you've got to, B will actually affect the shift left and right as well, and we'll get into that. So this will be our shift left and right in our parentheses, but we've got to make sure we look for B. And then this plus K is our shift up and down, and our sign stays the same. So to figure out your left endpoint, so a non-shifted function, the left endpoint means where we started. So we started at 0, we went around a full cycle to 2 pi. So if we take and shift those points left or right, you've now got to take your left endpoint 0, and you've got to figure out where the new endpoint will be. So what you'll do is you'll set bx minus c equal to 0 and solve for x. That will be your left endpoint. And then you'll set, to find your right endpoint, remember if we used to end up at 2 pi, but now we're shifting it over, then you would set bx minus c, this entire inside, equal to 2 pi, and then solve for x, and that would be your right endpoint. You'll see what I mean when we get to some examples. Okay, let me just make sure everybody's got that. This is where people mess up more. Okay, so we have this y equals 1/2 sine of x minus pi thirds. I go through every time and answer all these questions for myself. It just helps me get it right, and then if somebody ever said to you what's the period, you would know exactly how to do it. Like you've been practicing it every time you graph something. Okay, so first of all, our amplitude is what's multiplied in front, so our amplitude is 1/2. The number of cycles from 0 to 2 pi, you'll just take your b value, which is in front of x, which is 1, correct? B is 1. So the number of cycles from 0 to 2 pi is there's 1 cycle on the interval from 0 to 2 pi. Now our period is 2 pi divided by b. So that's the length of 1 full cycle. So that's 2 pi divided by 1, which is 2 pi. So the physical length of 1 cycle is going to be a length of 2 pi. That doesn't mean necessarily it's stretched over from 0 to 2 pi. Well, it is, but then we're shifting it. Now notice that because this a value is 1, we could just say, right, pi thirds. Everybody, isn't that true? Are we shifting it right pi thirds? Shift it left and right, you go opposite. So we're going right pi thirds. So let's write down what, if you think about it, well, we just be taking all of our points and adding pi thirds to each of those, right? That'd be shifting all of them right pi thirds. So you can think of this so many different ways. I sat and debated, like I said, I really did sit and say which is going to be easiest for them. So here's my left endpoint. It used to be at 0. We now shifted it right pi thirds. So when would that be? 0 plus pi thirds, which is pi thirds. So we're shifted over pi thirds. That's our starting point. And then our right endpoint is going to be, well, think about it. It used to end at 2 pi, but now it's shifted right pi thirds, so we'll be adding pi thirds. So we'd have to get a common denominator, so what do we get? 7 pi thirds. Okay, so, all right, let's start to graph this. So that's our first tick mark. Let's see, I want you to all catch up to me mentally before I start. So let me push pause. Okay, so let's start graphing this. So first of all, our amplitude is up a half. So we would go 1/2, -1/2. Now, we have a period, a full cycle is 2 pi, but now we've shifted it pi thirds. So we're graphing in one cycle. We started at 0, but we shifted it pi thirds. So I'm going to draw this new y-axis because that's my new starting point. So that's my new y-axis. We still have this normal x-axis though. Is everybody good up to there? So we know that our our left endpoint is pi thirds. So then 1, 2, 3, 4 is that's one cycle, right? 4 tick marks. So then that'll end at 7 pi thirds. Does everybody understand? It used to be at 2 pi, but we shifted it, right? Because normally it was at 0, right? And ended at 2 pi. But now we've shifted it right pi thirds. So you took 2 pi and added pi thirds. You get 7 pi thirds. So let's see if you can correctly think about this. Now we're having to graph 2 cycles. So 1, 2, 3, 4. Can anyone tell me what I'm going to be at correctly? Almost. Where would I be at if I add another cycle? No one knows? Not quite, we could try. 13 pi thirds. Why is it 13? Because from 0 to here is 7 pi thirds, correct? Now if we go another full distance, that would be 7 pi thirds plus 7 pi thirds, which is 14 pi thirds. But that is not starting at 0. That was starting at 0, correct? Yeah. So we got to subtract this shift of right pi thirds. We got to subtract pi thirds. So basically what you literally could just think of is normally if it wasn't shifted, didn't we end at 4 pi, guys? Everybody? Now we shifted it right pi thirds, so we'd just be adding pi thirds, which puts us at 13 pi thirds. Is anybody confused? Okay, 13 pi thirds. Okay, let's fill this in. So on this one, I actually get your calculators out because I don't want to have to wait for us to actually think about it and do it. Just let's use our calculators when we can. So let's fill in the rest of this x-axis here. So halfway between. So think about it, guys. If I said halfway between 7 pi thirds and pi thirds, well, there's so many ways you can do this. Like I said, I sat and debated which is going to be the easiest, but I just think from here's the easiest. So what's 7 pi thirds plus 1 pi thirds? 8 pi thirds, correct? But that you got to now divide that by 2. 8 pi thirds divided by 2. You don't type in the pi in your calculator. So 8 thirds divided by 2 is 4 pi thirds. So this distance right here is 4 pi thirds. This length from here to here. Everybody good? Well, we're doing the, do you get what we're doing? We're finding the halfway mark between pi thirds and 7 pi. So we can fill in our tick mark. No, 7 plus 1 is, oh no, you're right. That doesn't make sense because that's a distance of, wait. 1, no, yeah, this puts us at 4 pi thirds. Yeah, you got to add them up and then divide by 2. Yeah. Right. Is anybody confused? Okay, what's this halfway distance? 13 plus 7. Okay, so you did it already, but then you divided it by 2. Well, we're trying to find like the average distance, so you divide by 2. Well, I explained why it was, but you obviously weren't listening. Do I need to re-explain it? Are you sure? Okay, then halfway distance between these two. Pi plus 4 pi is... I can tell you're talking about. Stop. Holy... Okay, we're trying to find the distance between these 2 points, the halfway distance. So what do you take that distance, pi thirds, add it to that, 4 pi, and then divide it by 2. So 4 plus 1 is 5. We have 5 pi thirds divided by 2. Okay, so this is 5 pi 6. So now you do that same thing here. 7 plus 4 is 11 divided by 11 thirds divided by 2. So 11 pi 6. And then what's this one going to be? 17 pi 6. And then 13 plus 10 thirds, 23 pi thirds divided by, yep, so 23 pi 6, right? Now let me show you one other way. Let's say you absolutely loathe and hate doing it that way. Couldn't you think of it? Our normal points for x were 0, pi halves, pi, 3 pi halves, and 2 pi. And then the next one was the next cycle had 5 pi halves, correct? Do you guys understand what I'm saying? Like if we were doing the non-shifted one, and then that would be 6 pi halves, which is 3 pi, right? 7 pi halves, 8 pi, so 4 pi. Now wouldn't we just be shifting all of those points right? Pi thirds. So you'd add pi thirds, and get a common denominator, add pi thirds, add pi thirds. Do you see that would end, these would end up with these. You could do it by hand. Does that make sense, everybody? You can do it 2 different ways. I just think this was quicker. Okay. So if you took 4 pi and added pi thirds, we'd be good. Okay. Did I say pi thirds? Yeah. Okay, let's keep graphing this. Sorry. Now, what did we have originally? Okay. So now we're up at, so we know that sine looks like this, correct? So we start here because we're going to call this our new origin. Then we go up to the amplitude, back down to 0, back down to the bottom of the amplitude, back up to 0, because that's graphing one cycle for sine. Then we go up to the amplitude, down to 0, down here, and back up to 0. Ding, ding, ding. Questions on that? Okay. Okay, so let's do this one, right? You're going to want to write down these things. Okay, so our amplitude is 3. The number of cycles from 0 to 2 pi is a third, because b is the number of cycles, right? That's just 1/3 x, correct, everybody? Bx, so there's a third of a cycle drawn from 0 to 2 pi. Our period is 2 pi divided by b, so 2 pi divided by a third is 6 pi. The length of one cycle is going to be stretched over 6 pi units. And then are we shifting left and right at all? No. And then we're shifting up 5. Nope. So that's where I actually start, is my shifting up and down. So we're shifting up 5. 1, 2, 3, 4, 5. So that's our new midline, meaning our new x-axis. So I'm going to draw that out like that. I always draw a dotted line for my new x-axis. So our amplitude from there is 3. So if this is 5, up 1, 2, 3, because the amplitude is how high up or down from the midline, so that'll put me at 8, correct? You'd have to label it correctly. So down 1, 2, 3 puts me at 2. So now I just make sure like it even doesn't hurt. I'm gonna just do it colored to like put a dotted line so that you make sure your amplitude reaches between that. Okay, now we'll put in our x-axis. So there's no shift left and right. Luckily, these are the easiest ones with no shift left or right. So we're drawing in 2 cycles. 1, 2, 3, 4. So that'll be what? 6 pi. Then 1, 2, 3, 4, because we have to draw in 2 cycles, and since we didn't shift left or right, it was 0 to 6 pi, so this will be 12 pi. Halfway between 0 and 6 is 3 pi. Halfway between 3 and 0, 0 to 3 is 3 halves, correct? So 3 plus 0 is 3, divided by 2. So this is 3 pi halves. 6 plus 3 is 9. 9 divided by 2 is just 9 over 2, right? So this will be 9 pi halves. 6 and 12, 18 divided by 2 is 9. So this is 9 pi. 6 plus 9 is 15 pi halves. Because we're dividing it by 2 to make it the average. And then right here we have, yep, 20. Okay, so now we know this line looks like this. Ding, ding. And oh, it's a reflection over the x-axis. So we're going to still start at 0, correct? Now at this, it's going to be at the bottom of our amplitude. Is anybody confused? Then at this next point, it'll be to 0. Then at this point, it'll be at the top of the amplitude. Then at this point, it'll be back down to 0. So we've drawn in 1 cycle. It's just been shifted up and reflected. Now we go back down to the bottom of the amplitude for that point. At that point, it'll be 0. At that point, at the top of the amplitude. And at that point, back down to 0. Probably not. Try to remember the drum book. Okay, so just be careful because if we look at x plus 1 squared versus 4x plus 1 squared, that's a shift of left 1, but this is actually a shift of left 1/4 because you'd set that equal to 0 and then solve, and so it's actually a shift of left 1/4. So look at the difference between sine of x minus pi. We can literally just say it's right pi because there's nothing in front of x. But here we have something in front of x, a 2. So this isn't a shift just right pi. We would set that equal to 0. So we would go like this. To figure out the correct shift, we'd say 2x minus pi equals 0. Solve for x. So we'd add pi, divide by 2. So x equals pi halves. So it's a shift of positive pi halves, so right pi halves. And then we'd have to do it correctly. So just be careful if b is not 1. Does that make sense? Okay, so last 2 examples, and if you don't need one after this, I won't do another one. So if you feel good after this, I'll let you go. So here we go. My amplitude is it's 1, right? So we could rewrite this, and I would strongly suggest rewriting it. That's negative cosine of 2x minus pi plus 3. So a lot of people tend to say 3 is the amplitude, so this is a good example because we've got to be careful. Amplitude's multiplied in front, not added. So this is a amplitude of 1. Remember, amplitude is never negative. That's just a reflection over the x-axis. The number of cycles from 0 to 2 pi is? Nope. What's the number of cycles from 0 to 2 pi? 2. You just look at B. That is the number of cycles from 0 to 2 pi. The physical length of 1 full cycle is 2 pi divided by B, which is 2. So the physical length of 1 cycle is pi. And now our shift up or down is up 3. This one is probably one of the most hard ones. And then, unfortunately, we do have a shift left and right. But we can do it. So we're shifting right pi halves, correct, everybody? You'd add pi, divide by 2 to solve for x. So we're shifting right pi halves. Okay, So what I like to do is start out by saying, okay, so I've shifted up 3, so let's draw that in. Up 1, 2, 3. I like to put in my new dotted line for my new x-axis. Okay, now from there, our amplitude is up 1. So from the midline, we're going up 1, but this was 3, so isn't this going to be 4? And this will be 2. This was just a shift of up 3. Isn't it right? Good question. It's right. That's a good question because it's negative, right? Right. So now from there, we've got to shift right pi. So now we're going to go over here, and I'm going to put another dotted line. So we're going right pi. So right pi half. So now we're starting at pi halves instead of 0. Is everybody feeling okay about that? Okay, so then from there, we're treating this as our new origin. From there, we've got to go over 1, 2, 3, 4, because that's one full cycle. Now, careful, because we have the length of a cycle is pi, correct? But now, didn't we shift that pi halves? So we're taking all of our x values and we're adding pi. No, sorry, we're adding pi halves. So our left, I keep calling it left bound. Our left point is, our left x value will be 2x minus pi equals 0. So our x value for our left endpoint of our period is pi halves. That makes sense. 0 shifted pi halves. And then our right endpoint will be 2x minus pi equals 2 pi. Because if it wasn't shifted, wouldn't it end at 2 pi? Does everybody see what I'm doing? So I'm just adding pi halves, essentially. So I'd add pi divided by 2. Or you just take 2 pi and add pi halves. So that's 3 pi halves. So we're ending at 3 pi halves here. Is anybody confused? Okay, so now we're going to go another 1, 2, 3, 4 tick marks. And if we didn't shift, so let's just make it the easiest way possible. If it wasn't shifted, wouldn't we have ended at 4 pi? No, that's wrong. Wouldn't we have ended at 2 pi? Everybody? If we didn't shift left or right at all. Everybody see what I'm doing? So our second thing would be at 2 pi. So we take 2 pi and add pi half. Do you get that, everybody? Am I making sense? If it was not shifted, this would be 2 pi. Okay, so it's 5 pi halves.
Remember we were doing like 3 pi halves?
Yeah, absolutely. Say from here to here, so 3 pi halves plus 3 pi halves, and then subtract 1 pi halves. That's, like I said, there's so many different ways to think about these. That's why I sat and was like, what's going to be the easiest? Is anybody lost on how I got 5 pi halves? Yes. Yeah? Right here? This? Oh, I see what you're saying. Oh, yeah, but this was 3 pi halves. Because this was this value. Sorry. Yeah, it does kind of look like an 8. Now let's fill in the rest of the x-axis. Yes. Oh, no, pi half. Because we shifted from, if it wasn't shifted, we started from at 0 and we ended at pi, correct? Does that make sense? Oh, I wrote 2 pi, didn't I? No, I'm saying on top. Oh, on top. Oh, yeah, gotcha. Yeah, okay. All right, so the halfway point, 3 pi. So this is the easiest one, isn't this? Okay, so 3 plus 1 is 4 pi halves, which is 2 pi divided by 2. So that'll put us at pi here. Okay, and then this plus this divided by 2. So 1 plus 1 half. 1 plus 1 half would be 3 halves divided by 2. 3 pi, of course, isn't it? Okay. So 3 pi fourths. So think about it. Okay, let's just keep doing that. So 3 halves plus 1. Just do it in your calculator. Like, let's just get these out quick. Like, I just am saying. 1 plus 3 halves divided by 2. Yeah. So isn't this 1 pi, this is 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths. So I'm going to use that now. 7 pi fourths, 8 pi fourths is 8 pi fourths. Is 2 pi, very good. And 9 pi fourths. And then make sure you end up at the right place. 10 pi fourths does simplify to be 5 pi halves. Okay, now we can start graphing. So now, once again, this is negative cosine. So cosine looks like this, but now it's reflected. So start at the origin, and now instead of going, here's the origin, right? Cosine normally would start up here, but since it's reflected, won't it be, sorry, and I like to draw in usually those two. So we would be down at negative, we'd be down at 2, or up at 2, correct, everybody? Here at 2, right? And then we would be at back to, wait, what am I not thinking of? Oh, it's right here. Oops. Sorry. I'm thinking too hard. We're not thinking good enough. So we start down here, correct? Sorry, I like to have these in. That's what's throwing me off. Okay, so we start down here. Because it's a reflection over the x-axis. So instead of starting up here, we reflect it. Yeah, it's okay. So we have this down here, then it will go up to 0, correct? Up to the top of the amplitude, back to 0, and then back down to the bottom, correct? Did I draw that in right? Ding, ding, and connect that very good. And then once again, it's a reflection, so started down here, then went up to 0, up to the top of the amplitude, back down to 0, and to the bottom of the amplitude. So ding, ding. And you shouldn't drop below the amplitude, so I didn't draw that very good. Anyways, confused anybody? It is a lot to think about. That's as hard as it gets, though. That one was the hardest one. Yeah, you just gotta take it one step at a time. And sometimes, like I said, you could tell sometimes I start to overthink it or whatever. Okay. Do you want one last example, or do you feel okay? Should we do this one? Okay. Okay, you'll see that this one ends up kind of different than what you're used to. So it's a good one to go through. So we have our amplitude. Let's quickly see if we can be quicker at this. What's my amplitude? 2. Number of cycles from 0 to 2 pi. 3 pi halves. You're right. What's the period? 2 pi divided by 3 pi halves, correct? So let's do that. Let's do some algebra. That's 2 pi over 1, and then you flip the second and multiply. So multiply by 2 over 3 pi, correct? So isn't the pi's divide out in this one? So we have 4/3. The length of one cycle is 4/3. We're shifting up or down, none, and we're shifting left or right, none. Okay, sweet. So this one's, oh, we have a +5. You just saved a life. So up 5. So here we go. That's where I start. 1, 2, 3, 4, 5. Our amplitude is 2. So up 2 more would be at 7. Down would be at 3, correct? So I'm going to draw that in really quick so that I don't mess up. Okay, so now our period. So from there, since there's no shift left and right, we're just starting at 0. We love these ones because they're easier. So we're drawing in 2 cycles. 1, 2, 3, 4. And the length of that one cycle is 4/3. So add another 4/3. 1, 2, 3, 4. And what does that put me at? 8/3. They're not pi's, which is completely fine because this one's just the pi's already multiplied in. You know what I mean? The pi divided out, but this is just in physical radians instead of pi radians. Okay, so let's cut this in half. So won't that be 2/3? So this is 1/3. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. And now it's sine and reflected. Normal sine looks like that. So we start at 0. Then we're going down to negative. Down. It's hard to explain because I just like if I say down to the bottom of the amplitude, that's better. Up to 0, back up to the top of the amplitude, and back down to 0. Ding, ding. Now we're going back down. Yeah, this one was a reflection, so we went down instead of up, like normal sine. And then up to 0, to the top of the amplitude, and back down to 0. So we've finished. So don't let it throw you off if the bottom, the x values don't have pi's in them. It's totally fine. It's almost easier, yeah, to be honest. Yeah. What are the problems you're doing out of the book?